All right. Hi, everyone. Now we're going to go ahead and do some practice problems from the Chapter 5 material. So the first thing that we're going to do is we're going to work finding the z-score. So here's our z formula. And as we can see here, we're working with population data here because we have our mu and we have our lowercase sigma. So we know that we are working with population data here. So for a distribution with a mu or a population mean of 40 and a population standard deviation of 12, we're asked to find the following z-scores. So when we have an x or a raw score of 36, we set up the problem like this. Z equals 36 because that's my x, minus 40 because that's my mu, over 12 because that's my population standard deviation or my lowercase sigma. So from there, you're just going to do that subtraction and division. So you get -4 over 12. And when you do that division, you get -0.33. So that's how you find that z-score, -3.3. The next one asks us to find a z-score when we have an x or a raw score of 46. So we set it up the exact same way. Z equals 46 minus 40 because that's my population mean, over 12 because that is my population standard deviation. So here we get 10 over 12. When we do that division, we get, I'm sorry, not 10, we get 6. We get 6 over 12, and when you do that division, you get 0.5. So that's our z-score for that one. Next one here, we get, we set it up the exact same way, 56 minus 40 over 12, because that's my population mean and my population standard deviation. When I do that subtraction, I get 16 over 12, and when I do that division, I get 1.33. So that's how we do those types of problems. That's how we get our z-scores when we are given an x or a raw score. Now looking at these numbers, once we find our z-score, that tells us a little bit about where that raw score falls. So for this first one here, let me use a different color. We can see that this -0.33 is going to fall below the mean because that's a negative z-score. So here's my mean, 0. Remember that the mean in a z distribution is always 0. So my -3.3 is going to fall somewhere in this region, -0.33. So that's where that z-score is going to fall on the distribution. This next one here, 0.5, here's my mean. 0.5 is going to be right here. That's half a standard deviation past the mean on the right side of the distribution. This one here is a little farther out. Here's my mean again, 0. And we have our z-score of 1.33. So when we find that z-score, it can tell us a little bit about where the raw score, the x, falls on the distribution. So that's how we find our z-scores when we're given an x value. All right, now we're going to work these types of problems backwards. So now our problem is asking us for x values when we're given z values. So we're working with the same population parameters here. We've got a mu or a population mean of 40, and we have a population standard deviation of 12. So we have the same numbers that we're working with here, except this time we're asked for x values when given the z values, So the first one asks us to find x when we have a z of 1.5. And this is the formula that we're going to be working with. So if we're looking for x, we multiply our z times our standard deviation, and then we add our mean. So that's what we're going to be doing. So we set this up like this. x equals, so z is our 1.5. We multiply that by our population standard deviation, or lowercase sigma. And then we add our mean, which in this case it's 40. So that's how you set up that kind of problem. There might be a bit of a glare there. So no, it's not going to really help. So this says 1.5 times 12 plus 40, in case it's hard to read. So you go ahead and you do that multiplication there, and you get, the final answer comes out to be 58. The next one here, you set it up the same way. Negative 1.25 times 12 plus 40. This stuff stays the same because we're working with the same parameters for the population. So here we get a final answer of 25. So we multiply our 12 by our 1.25, and then we add 40, and we get 25 when we do that math. For this one here, we do our 0.33 times 12, and we add our 40. When you do that multiplication and then add, you get 43.96. So that's how you find your x value when you're given the z. So this is basically how you work the z formula backwards, using this formula here, x equals z times standard deviation plus mean. And you can do this same formula with sample data as well. So that formula is going to look like this. Exact same operations, just different, different symbols. So that's how you would work this with the sample. Same interpretation, same math that you're going to do, it's just different symbols for population and for sample. Okay, now we're going to do a practice problem where you're given raw data and asked to find z-scores from that. So the ones that we've done before, I've given you your standard deviation and your mean. This time, we're going to have to calculate mean and standard deviation. So here is your prompt. So for the following data set, an x, or a raw score of 4, is associated with what z-score? And here is our data set here. So the first thing that we're going to do is add our data set. So we do 5 plus 6 plus 4 plus 3 plus 2 plus 4 plus 1. That gives us 25. So that's the sum of our x. Let me move this down so we can see. 25 is the sum of our x. Then we're going to square this number, because we're going to need that for our standard deviation formula here, so to find our standard deviation. So we square our 25 and we get 625. So we've got the sum of our x's, then squared, which is 625. The next step that we need to do is do our x squared column like we've done in the past. So 5 squared, 25, 6 squared, 36, 4 squared, 16, 3 squared, 9, 2 squared, 4, 4 squared, 16, 1 squared, 1. Then you add up that column, and this gives you your sum of x's squared, x squareds. Sum of our x squareds. 25 plus 36 plus 16 plus 9 plus 4 plus 16 plus 1 gives us 107. So we take all this information and we put it into our standard deviation formula to find our S hat. So here's our S hat formula here. First thing it asked us to do is find the sum of our x squareds, which we already did. We found that that was 107. Then we do the sum of our x's then squared. That's this piece here, which was 625. We put that over our n, and if we count here, we find that our n is 1, 2, 3, 4, 5, 6, 7. So our n is 7. And down here we go 7 minus 1. So that's how we set up our standard deviation. So we do this math here. 107 minus 625 divided by 7, which is 89.29, we'll say. And then we do that subtraction down there and get 6. 107 minus 89.29 gives us 17.71, so that's going to be our numerator. Number 6. We divide that by 6 and we get square root of 2.95. We do that square root and we get 1.72. So this is our standard deviation, our S hat. So we'll need that for this piece here, the bottom piece of our Z formula. So if you see here, we're working towards this thing here. So that's our standard deviation. The last thing we need before moving to this formula here is this piece, our mean, our x bar. We find that by doing the sum divided by n. And earlier we found that n was 7, so this is going to be super easy. So our n is 7. Our sum was 25. N is 7. Let me move this down so we can see that. So x bar, our sum was 25, n was 7. We do that sum over our n, and we get 3.57. So now we've got all the pieces we need. We've got our sample mean. We've got our standard deviation. And we've got our x that was given to us in the problem. So now we can go to this formula here to find our z. So z equals x, which was given to us in the prompt, x of 4. So 4 minus the sample mean, which we found was 3.57, over sample standard deviation, which we found was 1.72. So you do that math, 4 minus 3.57 gives us 0.43, or 1.72. We get 0.25. So this is our z-score that we get associated with the raw score of 4. So our z-score is the standard score that we get when we standardize this raw score here. And if we plot that on our graph, let me move the camera down here. If we plot that on the graph, it looks something like this, 0.25, very close to the mean. So that's how you would do a problem like that from raw data. And again, if you have any questions about these types of problems, feel free to email me.